So June 2017, paper 4, unit 4 basically. I'll discuss the MCQs. You can also, if any question, if you know the answer, you can just state the answer so we can quickly move on. Ethanoic acid is a mixture, is mixed with water. What are the Bronsted and Lowry conjugate acid-base pair? Acids are proton donors, bases are proton acceptor. Means the substance which donate the proton, we call that as acid, and the substance which gain, we call that as base. So when we check CH3COH becomes CH3CO. So for forward reaction, so this is a forward reaction. So CH3, so it is donating proton. So if a substance is donating proton, what we call? We call that as acid. And H2O, so for conjugate acid, the base one, because for reverse what happened, we are finding a pair. So if this is an acid, so opposite one will be a base. So this will be acid one and base one. And same thing, water is accepting protons. So water is a base and H3O is a acid. So C is the right answer. So for acid, there will be a conjugate base. Which of the following substance give a solution with the highest pH when equal amount of same volume of water is added? So highest pH. So for conjugate, like for weak acid, they have a strong base, and for strong acid, they have a weak base. So when we check the options for question 2, look, acetic acid, so it will have a pH less than 7. Again, the salt of acetic acid, here CH2ClCOH, but acetic acid is there, so it will also have a pH less than 7. Then this CH3COL, so when this CH3 ethynyl chloride, if you learn the reaction of ethynyl chloride plus water, so as a result it produces alcohol, carboxylic acid, CC double bonded with OH plus HCl. So again the pH will be less than 7 because acids are produced. The question is which is having the highest. So this is a salt, or we can also say it's a conjugate base because ethanoic acid like CH3COOH, so when it will dissociate into CH3COO and H plus. So this is the acid, this one is a conjugate base. Conjugate base, if we have a weak acid, it will have a strong conjugate base. So means this will have a greater tendency to accept proton. So when we have a salt of CH3 COO, it will dissociate into what? When we add water, it will dissociate into CH3CO and Na. And what is the tendency of CH3CO acetate ion? It has a tendency to accept proton. So when it will accept proton from the water will left with more OH ion. So if it is left with more OH ion, it will make a solution alkaline, or it will have a pH more than 7. Is it clear? In question 3, the calibration of a pH meter is best carried out. So how we calibrate a pH, because whenever pH meters are used, first always calibration is done. So which substance we should calibrate? The solutions which are not changing the pH. So which solution does not change the pH? Because even a strong acid or strong alkalis, they have a range of a pH. They don't have a fixed pH. But when we have a buffer solution, the buffer solution, even it's an acidic buffer or an alkaline buffer, it does not change the pH or it resists the change in pH. So that's why to calibrate the pH meter, we should use alkaline and acidic buffer. So A is the right answer, because if we can try to calibrate with strong acid, so maybe strong acid might have a pH 1 or 1.1 or 1.2. So we cannot identify whether it is calibrated correctly. So the best way to check, because the buffer solution resists the change in pH, so their pH does not change. So we can put in acidic or alkaline buffers. So if any question you are not able to understand, just let me know, so I'll repeat at the same time. The next, the pH of the following solutions using the dissociation constant Kw 1 exponent minus 14 where necessary. Zero point 0.2 moles of nitric acid. What is a nitric acid? Nitric acid is a strong acid. And strong acid ionized completely. As a result, the concentration of the acid is same as the concentration of hydrogen ion. So if you have 0.2 moles of nitric acid, all 0.2 will dissociate, like, or in the beginning it is 0 0, but at equilibrium all, we can assume, this is our assumption, that all will dissociate into ion. So we'll use a formula. The hydrogen ion concentration is there, then we'll use the formula pH equals minus log of hydrogen ion. So it will be minus logarithm of 0.2, the pH of this nitric acid solution. So it will come out, when we substitute the value, it will come out as 0.7. So D will be the right answer. The next one, 0.2 moles of barium hydroxide. Barium hydroxide is not a strong alkali. So the barium hydroxide will dissociate into one barium ion and two hydroxide ions. So if initial concentration is 0.2, this will be 0 and 0. At equilibrium, if we say X is used up, so this will be 0.2 minus X, this will be X, and this will be 2X. Why 2X? Because 1 mole of barium hydroxide gives 2 moles of hydroxide ion. So if this is produce X, this will be 2X, and this is 0.2 minus X, because that is the amount which is used up. So we will use a formula. First we'll find the concentration of hydroxide ion. In the beginning of the question, they already mentioned, or they already give us, so barium hydroxide is there. So this will be, so our assumption here, as the Kb is not given, we'll assume that all will dissociate. If all will dissociate, then the concentration will change, as a ratio between barium hydroxide to hydroxide ion is 1:2. So if this is 0.2, how many moles at equilibrium will be there? 0.4. So we'll have the concentration to be 0.4. And now the concentration of hydrogen ion and the hydroxide ion, the Kw is equals to 1 into 10 to the power minus 14. So we have the concentration of hydroxide ion, which is 0.4. So hydrogen ion into 0.4 is equals to 1 into 10 to the power minus 14. Or 1 into 10 to the power minus 14 divided by 0.4 will give us the hydrogen ion concentration. And using the hydrogen ion concentration, we'll use the formula pH equal minus log of hydrogen ion. So when we substitute the value pH equal minus log of hydrogen ion concentration, so this will give us 13.6 cm3. A mixture of 10 cm3 of 1 mole per dm cube hydrochloric acid and 20 cm3 of 1 mole per dm cube sodium hydroxide. So first we have to find a limiting reagent, because the limiting reagent will be used up in excess reagent. Like we should know, how many moles will be left, and the new concentration because the two solutions are mixed together. So the formula between hydrochloric acid HCl and sodium hydroxide, when they react with each other, it will give sodium chloride plus water H2O. So 10 cm cube 0.1. So how many moles of hydrochloric acid? It will be 10 divided by 1000 to convert into dm cube and multiply by 1. So it will be the same answer. So 10 divided by 1000 equals to 0.01. So we will have 0.01 moles of hydrochloric acid and we'll have 0.02 moles of sodium hydroxide according to the values which are given. So hydrochloric acid is a limiting reagent as ratio is 1:1. So hydrochloric acid will be used up, and how many moles will be left once hydrochloric acid is used up? So we are left with 0.01 moles of NaOH, because 1:1 is the ratio. So 0.1 is 0.01, 0.01 will be used up and left with the 0. Remaining, which is 0.01. So these are the moles left. And what is the new concentration of sodium hydroxide now? So the volume here, it is 10 cm cube because we mix the two solutions together. So new volume is 30 cm cube. So 0.01 divided by, because we are finding a moles, so multiply by, uh, concentration we are finding. So moles divided by volume will give us a concentration. So 0.01 moles of sodium hydroxide divided by volume, which is 0.03, as the total volume of the solution. So 0.01 divided by 0.03, that will give us 0.33. So 0.33 is the concentration of hydroxide ion, because sodium hydroxide, the concentration of sodium hydroxide will be same as concentration of hydroxide ion, as it dissociate completely. Strong alkali dissociate completely. So now we have the concentration of hydroxide ion. Again, we'll use a formula that the hydrogen ion concentration and the hydroxide ion concentration will be equal to 1 into 10 to the power minus 14. So we'll have hydroxide ion concentration 1 into 10 to the power 14. We'll find hydrogen ion, and using the hydrogen ion, we'll find the pH, which is equals to minus log of hydrogen ion. So when we substitute these values, this will give us the pH of the solution, which will come out as 13.5. Then a buffer solution is prepared by mixing 20 cm cube of 0.1 mole per dm cube methanoic acid and 10 cm cube of 0.1 mole per dm cube sodium hydroxide. So buffer solution, weak acid and its salt, and the pKa is given. So what we can do, this is giving us the concentration of acid, and this one is giving us the concentration of the salt, because the alkali is a limiting reagent, like methanoic acid is HCOH, and it mixed with sodium hydroxide NaOH. So as a result, what it produces? It produces HCOONA plus H2O. So you can clearly see we are using the same concentration but small volume of sodium hydroxide. So sodium hydroxide is a limiting reagent. So if it is a limiting reagent, so in the solution, amount of acid salt produced is equivalent to amount of sodium hydroxide, like the moles of sodium hydroxide, and the amount of the acid, as you can see here, the amount of acid will be used up, not completely, it is in excess or more than enough. So we want to find, and the pKa is given. So the formula, the concept is concentration of acid divided by concentration of a salt. We can use that to work out the pH of a buffer. So we have the volume and the concentration. So using the volume and concentration, we'll get the moles equal concentration into volume. So 0.1 times 20 divided by 1000, because the volume should always be in decimeter cube. So that is 0.1 multiplied by 20 divided by, sorry, yeah, 0.1 multiplied by 20 divided by 1000, that is equivalent to 0.002. So 0.002 moles are used, and how many moles of alkali used? 10 times zero point 0.1 divided by 1000, that is 0.002. So 0.002 moles are used for this one. This will be 0 and 0 initially, but when they react with each other, sodium hydroxide is used up. How many are left? Because 1:1 is the ratio, 0.001 used up. So how many left? 0.02 minus 0.01. So it will be left with 0.01. And how many moles of as salt will be there? 0.001, because the limiting reagent, the sodium hydroxide we use, and water we don't need. Then what is the concentration? The new concentration, because concentration is moles divided by volume. So 20 cm cube of and 10 cm cube, so total volume is 30, and 30 cm cube divided by 1000, so which is 0.03. So 0.03 here and 0.03 here. So 0.001 divided by 0.03 equal to 0.03 here, and this will be 0.03. So we'll have the concentration of the acetate ion will be same as concentration of the salt, because all the acetate ion is coming up from the salt, from this one, because salt will dissociate the molecule of acid, sorry, all the ions HCO is coming from the salt, but this HCOH will not dissociate as it is a strong acid. So when we write, like we if we sorry, as it is a weak acid, so when we have a weak acid HCOH, as it dissociate, it will dissociate into HCO plus hydrogen ion. So original concentration, this is 0.002, this is 0.002, oh, sorry, 0.003, as I mentioned here. Like if we say initial, the buffer solution contain the equal amount. So when we write the expression here, I can substitute the values later. So when I write the expression, the Ka is equals to minus Ka is equals to the product divided by reactant. So it will be HCOO, the hydrogen ion, and divided by the concentration of acid, HCOH. How to get from pKa, how this formula can be modified to pKa? We have the concentration 0.03 for acid, and we have 0.0, so their concentrations are same. So if their concentrations are same, it means I can cancel these two numbers. Like these two, as their concentration are same, they will cancel out. So it means the Ka is equals to hydrogen ion. If K is equals to hydrogen ion, when we take logarithm both sides, so we can also say pK is equals to pH. So pK and pH will be same. So what is the value for pK? That is 3.8. So pH should also be 3.8 for this solution. Is it clear? Discussion? In this question, question 5, the decomposition of a hydrogen iodide at 500 Kelvin is in equilibrium. As you can see here, the equation 1. What is the effect of increasing the pressure on the mixture on rate of a reaction, equilibrium, yield, and Kc? Pressure, because you check the number of moles of gas, 1 mole, total half and half, so 1 mole. So the pressure should not switch the equilibrium, or pressure should not affect the equilibrium. Like it will not shift the equilibrium towards right or left. So either A will be answer or B. Then what is the relation between the rate and the pressure? Rate and pressure are directly proportional. If you increase the pressure, the rate will also increase. So we are left with increase, the rate should increase, equilibrium no change, and if equilibrium, and Kc or Kp is only affected by temperature. If we change the temperature, then only the value of Kc will change, otherwise it does not change. That's why A is the right answer. The equation can also be written, as I mentioned, which combination of expression is correct. So we change the equation. First we were using the half mole, now we are using the, first we are using a 1 mole, now it is for 2 moles. So enthalpy change for the first reaction is 5. For the second reaction, delta H, 2 moles are there, delta H2. So basically it will be double, or we can say delta H2 will be equal to twice of delta H1. Why I'm saying like this? As you can see, the first one we use 1 mole. Here 1 mole was used for hydrogen iodide. But in the second reaction, we are using 2 moles. So we double the moles, so enthalpy change will be double. So we can say delta H2 is equals to 2 delta H1, or delta H1 equals to delta H2 divided by 2 equals to delta H1. So which is it representing a half? So either B can be answer or D can be an answer. And what about the Kc for K1 and 2? When you write the expression for Kc, so the first Kc was a product divided by reactant. So hydrogen, under root hydrogen, because half means under root, and iodine divided by hydrogen iodide. And the second equation we have, so basically like this is Kc1, and Kc2, when we write for Kc2, the product, the hydrogen iodine divided by hydrogen iodide square, because what is the coefficient, that will be the power. So how the two expressions can be related with each other? So if I take a root both side, so I can say the Kc1, because then the right hand side will be same, so I can say Kc1 is equals to under root Kc2. So Kc1 is equals to under root Kc2, and enthalpy change of the first reaction is half of enthalpy change of the second reaction. Is it clear, this question? The dissociation constant Kw increases with increasing in temperature. Which of these statements about the effect of increasing temperature is correct? Look, when we increase the temperature, more molecules of the water H2O dissociate into H plus and OHI, because the reaction is endothermic. So as the reaction is endothermic, it increases the amount of hydrogen ion. As we supply heat energy, as we know, the formula pH is equals to minus log of hydrogen ion concentration. So when this reaction is endothermic, so when we supply energy, more hydrogen ions are released. More hydrogen ions are released, so amount of hydrogen ion increases, so the pH of the solution will decrease. But that does not mean water will be acidic. It will have equal amount of hydrogen, because if it produce more hydrogen, it is also producing more hydroxide ion. but the pH of a solution is refers to amount of hydrogen ion. So comparative amount of hydrogen ion is more compared to at 25. That's why. So if I say I have two containers filled with equal amount of water but at different temperature. So say this is at 25. So at 25 degrees centigrade, it contains 10 hydrogen ion and it contains 10 hydroxide ion. So, so 10 hydrogen ions are there, 10 hydroxide ions are there, OH ions. So the water, say pH is 7. But when we increase the temperature, because the reaction is endothermic, so it produce more hydrogen and hydroxide ion. So as a result, maybe 20 hydrogen ions are there and 20 hydroxide ions are there. So because this solution comparatively contain more hydrogen ions, that's why its solution pH will be less than 7. But that does not mean it will be acidic. Acidity or alkalinity depends on the like whether which hydrogen ions are more or hydroxide ion are more. So if hydroxide ion are more, the overall solution will be alkaline. If hydrogen ions are more, the overall solution will be acidic. But in this case, pH will be less than 7, but the solution will remain neutral. So C was the right answer, that the pH of the water decreases. Ethynyl chloride reacted with equal amount of, so if we have ethynyl chloride CH3, C double bonded with O and Cl. So if it react with ammonia, NH3, and with NH and H, partial negative, so they will displace. C double bonded with O and NH2 will be there. So it will form not amine. Amine means like NH, carbon and nitrogen group should be there. This is amide, C double bonded with O. Same thing, methylamine, when it mixes with methylamine, it will form amide. That is true. Because if it was a methylamine, say CH2 and CH3, methylamide is there. So it will form amide. Water to form a weak acidic solution, that is wrong. It forms a strong acidic solution because the HCl is produced. So that is, this statement is also wrong. B is the right answer. This is wrong because it produces amide. This is wrong because it produces hydrochloric acid, and it react with methanol to form ethyl methanoate. Actually, it will be methyl ethanoate, not ethyl methanoate. So the formula is, the name is written incorrect. In question 8, when optically active isomer is there, 2-chlorobutane react with a hydroxide ion to form butanediol, SN1 mechanism. The product is not optically active. So SN1 reaction means tertiary halogen alkane undergo SN1 reaction. First the bond will break and then the bond will form. So what is the best explanation why the product is not optically active? 2-chlorobutane, if it contain a chiral carbon, then it means it should be optically active. The reaction is nucleophilic substitution reaction. That is true, but that does not explain why the product is not optically active. 2-chlorobutane form in a transition state has a chiral carbon at the reaction site. So again, that is not explaining the idea, because what happened, first the bond will break and then the bond will form. Like here it is C2H5 and CH3 is there. chlorine is attached. One side chlorine is attached. Hydrogen is there and chlorine. So first in SN1 reaction, the bond breaking will occur. So it will form a carbon cation. And then the carbon cation which is formed here is a planar. Like three bonds are there planar. So attacking nucleophile can attack from the left hand side or it can attack from the right hand side. So it is having a chiral carbon. And this chiral carbon, because it's like the idea is that in the attacking nucleophile can attack from the left hand side or it can attack from the right hand side. So as a result, what happened, it will produce an racemic mixture. As a result of a racemic mixture, the product will be optically inactive. So D is the right answer. Like both possibilities are there, 50% chance that nucleophile can attack from left hand side, right hand side, 50% chance the nucleophile can attack from the left hand side. Then which of the following has enthalpy change equal to enthalpy change of a solution? So enthalpy change of a solution when ions, basically ions in a gaseous state, the hydration energies when ions in the gaseous state form a dissolve aqueous. The lattice energy when ions in the gaseous state will form a compound. And enthalpy of a solution is when a solid dissolves. So that's called enthalpy of solution. So solid, 1 mole of a solid dissolve in excess of water to form an ion. So B is the right answer. This is actually a definition of enthalpy of solution. Then a solid dissolve and turn into ions. The condition, it should be excess of water, not limited, because there are a lot of water molecules around them. It's not like two moles of H2O means like one water molecule surround potassium, one molecule surround chlorine. No, the idea is that when it dissociates into ion, many water molecules surround these ions. That's why it is written excess of water. So the ionic solid dissolve in water. Which of the following statement about the sign of standard enthalpy change is possible? Enthalpy change of a solution is equals to hydration minus lattice. Hydration energy is negative. Lattice energy is also negative. Both are negative because they are both bond forming. Hydration energy when ions form in a gaseous state form a bond with water molecule in solution, and lattice energy when ions in the gaseous state come together and form a compound. But the enthalpy change should be positive here for a substance to dissolve, because substance cannot dissolve if enthalpy change is negative. So enthalpy of a solution should be positive to dissolve. Hydration energy, because it's a bond forming, it is always negative, and lattice energy is also. The formula is enthalpy of solution is hydration minus lattice. So hydrogen will be negative and this lattice is also negative, so minus minus will be plus. So the question is, an ionic solid dissolve in water, and which of the following statement about the signs of these standard enthalpy change possible? So if a substance dissolve in water, because the total entropy, the hydration energy is negative, lattice energy is negative, that is always. And the enthalpy of the solution for a substance to dissolve, because the entropy of a surrounding should be negative, and how the entropy of a surrounding is negative, that is minus delta H by T. So this delta H is positive, the entropy of a surrounding will be negative. So the option, the ionic solid dissolve in water, which of the following statement about the signs of these standard enthalpy change is possible? So if hydration is always negative, lattice is negative. If you check, even they're asking, if we say hydration is negative, lattice energy is positive, so this is negative, this is positive, so always the answer. But the idea, because the lattice energy and hydration energies are always exothermic, that's why they should be negative. And the enthalpy of the solution or enthalpy change of a solution should be positive. So hydration and lattice can never be positive, they are always negative. Enthalpy of solution can be negative, can be positive. What is the main reason of hydrogenation of vegetable oil using a low fat spread? Like that is how margarine are made. So what is the main purpose for hydrogenation of vegetable oil for use of low fat spread? Because what happens when we do hydrogenation, it increases the melting temperature. Like maybe you have heard saturated and unsaturated fat. So what is the main reason of hydrogenation of vegetable oil for use of low fat spread? Like we don't want to spread them faster, quickly. So if we don't want to spread them, so it means we want to increase the temperature, and hydrogenation will increase their temperature. To increase the melting points, it does not melt at low temperature, because if it can melt at low temperature, it can spread easily. So basically we are increasing the viscosity rather than decreasing the viscosity. In question 12, which of the following statement is true? The trans fat has hydrogen atom in the trans position attached to carbon-carbon double bond. That's the basically a correct statement. The trans fat is having a hydrogen atom in the trans position. The trans esterification always produce ester with hydrogen atom. That is wrong. Butanene has cis and trans. Butanene does not have an geometrical isomer. 1 fluoro, 1 chloro, 2 bromo, 2 iodo has a cis and trans isomer. So when whenever two different groups are there, it is not a cis and trans, it is E and Z. Cis and trans are for identical groups. That's why statement D is also incorrect. Is it clear, this one? In separation, using a high performance liquid chromatography, stationary phase was a polar and mobile phase is a non-polar. So like the idea is that identical type of molecule attract the identical substance. So which compound would take the most time to travel through a column? So the mobile phase is a non-polar and the stationary phase is a polar. So it will attract, stationary phase will attract the polar substance. So which is the most polar? Like here, this is non-polar. So these are polar. Which will be the most polar? Because chlorine is more electronegative. So its bond is more polar than bromine and iodine. So it will be attracted more towards the stationary phase. As more attraction towards the stationary phase, it will move slowly through the high performance liquid chromatography. Then ricinoleic acid, which is found in castor oil, is a painkiller. What is the systematic name? So how to work out the systematic name? First thing, we'll check the heavy groups. The heavy group are connected down the same side. So if the heavy groups are connected in the same side, it should be Z. Not cis or trans. Cis or trans is for identical heavy group. But it is because different heavy groups are there, so either it can be E or Z, but heavy groups are on the same side, that is why it is Z here. Then Now, what is the name? If I count the carbon atoms, one, two, three, because this is the first, because the functional group when carboxylic acid and alcohol, so we give priority to the carboxylic acid. So one, two, three, four, five, six, seven, eight, ninth carbon is having a double bond. 10, 11, 12 is there is at the 12th position we have OH. So 12th position, it is a Z first thing, so it cannot be A or B because the heavy groups are on the same side. So Z, and 12th position we have a hydroxy, and ninth position we have a double bond, that's why 9 in oic acid. So D is the right answer. Then the tallest peak in the mass spectrum is 55. Which fragment produces? So you have to find the mass which is having a total mass of 55. So basically just add 12 plus 16, 32 plus 12, 44. This will be 45, so it won't be. This will be 12 multiplied by 4, 48, and plus 7. So 55, so B is the right answer. Just add the total mass of atoms present in the peak. And which polymer is manufactured by condensation polymerization of a single substance? So basically this is by addition polymerization, because in a condensation polymerization there should be H and OH. So in a lactic acid, polylactic acid, the idea like C double bonded with O, one side it will lose H, another side it will lose OH. Here why this is, first B and C cannot, A and B cannot be an answer because they are showing addition polymer, carbon chains are linked. We want a condensation polymer. So how to identify, because if one side we page H, one side OH. So this does not suits the structure, like you don't have HOO. So one side if we put H, another side we put OH, so it means this is, or one side, this is the right structure because it lose one side H, another side OH, and it form a long chain compound. So D will be the right answer. Is it clear, this question?